It enables societies to advance. But innovations need to be understood and trusted and lift us all. In AI, medical, space, climate, technology unlocks human potential. And rules we design today are as important as the technology we create. It's how business delivers technology safely into our hands, and how countries leverage innovation. This partnership between transformative technology and purposeful policy drives growth, ensures investment, builds better societies, and powers human progress. We make innovation work for the world.
Good afternoon, good evening, and to everyone wherever you are. And if it's good morning for to you, I hope you had a good rest after a topsy-turvy day yesterday. Uh, what happens when engines of innovation are pushed to their limits? We have all heard about semiconductors, how they are central to AI-driven transformation, and how they have experiences unprecedented growth fueled by the soaring AI demand. However, despite geopolitical tensions, despite supply chain concerns, this critical industry is booming and playing a pivotal role in shaping the future of global economy. Uh, During today's brief, we'll talk a bit about the challenges of meeting the skyrocketing AI demand. We'll talk about the impact of geopolitical dynamics and discuss some strategies to strengthen these supply chains. I have two distinguished speakers with me today. Ricardo Masuki, who heads the Brussels office, managing director of EU affairs at Intel. He leads Intel's advocacy with EU institutions, trade associations, think tanks, and other stakeholders in Brussels. Throughout his career, he has developed significant experience in AI, data, cybersecurity policies, and has held several leadership positions in influential industry groups such as Digital Europe and Cybersecurity Coalition. He is a member of OECD's Semiconductor Expert Group Network and a technology policy visiting scholar at Duke University. And joining me is also Colin Christie, who is the chair of advisory council at Analytics and Artificial Intelligence Association of the Philippines. He's an entrepreneur, he's an educator, he's a global connector, specializing in Gen AI, its impact of work, life, education. Uh, Long career, he's co-founded the AAP, served as his board president, and now chairs the advisory committee. He's been an independent director of Now Corporation, a director of LifeTrack Medical Systems. Basically, all in all, he understands the supply chain from start to the end, right? Uh, and joining me, Abhinit Kaur, director with Access Partnership. Uh, what we witnessed, we already have seen the elections, US election today, and the good news is that AI and semiconductors are on the bipartisan agenda. So the principle should not broadly change based on the results. We obviously have to wait and see the mechanisms to drive AI and semiconductors forward. So let's, gentlemen, drive straight into the agenda and address the elephant in the room. No pun intended here at the GOP victory. But let's talk about the geopolitical factors and supply chain resilience. Given that the geopolitical landscape and how what we are seeing right now, how can nations and companies collaborate to ensure a resilient supply chain, semiconductor supply chain that transcends these political tensions? Maybe, Ricardo, I start with you.
Thanks, Abhinit, and thanks also to Access Partnership for this kind invitation. Thrilled to be here today, especially to discuss this topic. I To your question, I think it's clear across the world that there's a need for more resilient supply chains, and actually the need to reduce dependencies on regions, and a broader need for rebalancing the global supply chain by strengthening regional supply chains. I'm based in Europe. I followed very closely the European Chips Act development, but I also followed what the US have done over the last couple of years with their US Chips Act. There's a clear acknowledgement that regions like Europe and the US that just 30 years ago had a large at the largest percentage of semiconductor production. Together, they accounted for 80% of the global production. Now they account for 20%, with Europe accounting for maybe 7-8%, and the US roughly 12%. So what can be done to rebalance the supply chain by reducing dependencies on Asia? So increasing capacity capabilities both in Europe and in the US, while knowing that the semiconductor supply chain remains global. And this is linked also to the technology complexity of semiconductors and the increased specialization that we saw over the last decades, to the point that at the moment we have some single players and some single suppliers, right? Um, 20, 30 years ago, actually at the beginning of the year 2000s, there were probably 25 players at the leading edge. So those able to design and manufacture at the forefront, no, at the leading edge, the most advanced nodes. Now there are three companies, Intel, TSMC, and Samsung, that can manufacture at the leading edge. So what is the situation now? Certainly, we cannot achieve autonomy, nor we can duplicate every single step and segment of supply chain. And so we need to strike a bit of a balance, because moving from just-in-time supply chains to just-in-case supply chains, so supply chains that are able to resist also to disruptions, to shortages, all this drives costs up. And so we need to also to strike a balance of what is possible and what is also business viable. And so I think we should look more at the complementarity of ecosystems. The transatlantic ecosystem could be a first good example, starting from more information sharing, more early warning mechanisms, also to make sure that we can predict shortages. And to conclude here, I think an interesting framework could be the one that is offered by the OECD, where many of the countries that are like-minded can work together, the US, the European Union, but also Korea, Japan, because I think that we need to bring to the next level what is coordination, information sharing, capacity building, and actually explore what does it mean really, the concept of not only reshoring, but also friendshoring, nearshoring. And so countries like Costa Rica, Mexico, for instance, will play a very important role for the US. But there are also other countries in Asia that can play, and Latin America, that can play a very important role going forward to have a more resilient global supply chain.
I think you talked about one key important region, the transatlantic partnership. And Colin, you are in the center of what I call the ring of silicon, what we used to call ring of fire, ring of silicon, because everybody is manufacturing chips these days, and those who are not are going to manufacture, whether it's Indonesia, whether it's Japan, all of them have plans there. What are your views? How do you see the countries coming together and trying to ensure that with all these issues, we can mitigate the potential disruptions?
Yeah. Well, also, I'd like to thank Access Partnership for involving me, and it's fabulous to be with you, Annette and Ricardo. I've been watching this for maybe an embarrassingly long period of time. I was counting it up this morning. I entered the Semiconductors as a wet behind the ears young engineer 43 years ago in Silicon Valley and Silicon Desert, we used to call it, in Arizona. Back then, I think in Arizona alone, there was over 150,000 engineers and production folks building chips. And then Silicon Valley was actually Silicon Valley. It's never been renamed Software Valley, but it's got nothing really to do with building silicon anymore. And back then, it was even hard to conceive that we would be, 4 decades later in this type of world. And I think there was a gigantic pendulum, that swung over the first 20 years over those 4 decades. And then I think what happened was COVID and the supply chain disruption was just one gigantic wake-up call to the world, really. And I think what suddenly became painfully on people's minds is how undervalued the resilience and sustainability of the semiconductor supply chain was. I think it had been way underestimated, and what an amazing ripple effect it could have across virtually every major vertical that does manufacturing. I mean, chips are in everything now, right? So I think this question of, what do we do even in the face of sort of the geopolitical tensions that are there to bring back resilience? I think Ricardo gave a really great formulation. To me, I think of 4 key pillars that we need to focus on. First is diversifying production. So that was already sort of addressed. And as you said, everybody now sort of wants to have a chip factory. They're even talking here in the Philippines. I've been here about more than a decade. It's largely been known as the back end, assembly test part of the process. But I think there's even talk now about front end, wafer fab here. So that's one. The second is we need to continue to work to strengthen the alliances, right? So, of course, we all, I think probably on this call, know about the CHIPS Act and its, goals to really bring up the share of global semiconductor manufacturing, for the U.S. From 10% up to 14% over the next decade. And then likewise, Europe, has the EU CHIPS Act, and also with similar sort of aims. And I think, there are some great alliances underway. There's the Trade and Technology Council, for the US-EU collaboration, for example. There's some joint R&D initiatives. But I think this is an area that still needs significantly more support and focus. And then just really quickly, the other 2 pillars, I think, are around transparency and cooperation. People are always sort of like feeling out the other side, and we've got to really build the trust and idea that this truly is a global market, and there's not going to be winners and losers. There are only going to be winners, or there's only going to be losers. It's going to be one or the other, right? So we really have to have that cooperation. And then lastly, I think we need to remember that we have to remember sustainability. And the biggest threat right now to sustainability in this sector is the energy, required to drive this. Both, I think, we can sort of bring AI, there's sort of, I'm with AAP, the AI and Analytics Association, bring AI into the picture. We all have heard the news reports about the increase in electricity demand that's going to be happening in very short order. And this is going to affect, the sustainability. So I think maybe, can dive into each of those a little bit more deeply, but I think those are kind of the framework of where the focus needs to be.
And that's aptly put, because there will be, it's not just the regional cooperation, there's also future of AI innovation. The fact that without creating these new ways of doing things, some of these things in the future track is not really feasible right now. So just getting to that point on the future of AI innovation, what do you think are the primary technology bottlenecks today in AI innovation? You talked about power limitation. There obviously talks about lithography advancements. So how do you think that will impact the future innovation? What do you think are some of the things that are happening today which potentially could help solve some of these problems? Colin, maybe we'll start with you.
So, well, you already touched on a couple. There's many, but I think we could probably say the 3 big boulders are, you mentioned a couple. One that we just mentioned, which is the power issue, right? So this is going to have to be addressed. And, there's a lot of innovation happening now around sort of next Gen 3 and Gen 4 nuclear and compact nuclear. This is perhaps a solution. Lithography, this is goes hand in hand with the increasing challenge around, sort of Moore's law. And we all know, Gordon Moore was one of the 3 principal founders of Intel. We've all been living off his, predictions for decades now, but it's becoming increasingly difficult. And the center of that is lithography. So there needs to be huge collaboration around R&D to overcome that. And I think the third one is specialization of the supply chain. I think this is also a little bit underappreciated, that we have a global supply chain already, but the problem is it's little bit of a misnomer, because there's such high specialization that certain elements of the supply chain are limited to very narrow geographic areas, like lithography, right? So, it largely comes out of the Netherlands, so not a lot of other sources for the lithography. And you can actually go through all the major areas of the supply chain and discover that actually they're only supplied by very small geographic sectors. And I think that needs to be diversified as well.
Yes. Yeah.
And it brings me to you, Ricardo. I think we were talking about how Intel is looking at it from a different perspective, from an open perspective. Maybe you could highlight a bit more about that.
Sure. I wanted also to build on some of the comments that Colin made, and he kindly also referred to Moore's law, and this. In the end, for decades, engineers have been trying to increase performance while making the energy consumption more efficient. And this is still, power, performance, area. These are still the criteria to define the best design, and we can expect that this will continue. Now, since we are facing, as you defined, Abinit, a skyrocketing demand for AI and for chips that are enabling AI, I think it's interesting to see what is available, and also what companies like Intel are trying to achieve going forward. At the moment, I think it's promising. It's very promising to look at what industry is doing in terms of advanced packaging, and so heterogeneous integration that does not only continue to shrink the number of transistors per an even smaller area, but is also trying to package in a different way chips in a way that there are some chiplet solutions that can improve the performance, and in some cases also substantially lower the energy consumption of that system. Another promising deployment is the use of AI at the edge, and Intel has launched AI PCs this year. We're going to increase even more the use of those products in 2025. And again, it's not only AI happening in the data center, but it's AI happening at the edge, and so closer to the final user. And then if we look a bit in the future, what is the direction of R&D? At Intel, we are looking at ways to somehow replicate what the brain is doing through neuromorphic computing. We created a research community that is looking at neuromorphic computing, so that we can drive more energy efficiency instead of processing ginormous quantities of data, which is what AI transformers are doing now, but trying also to process a smaller number of data and driving this in this way more performance, but also more energy efficiency.
Yeah,
go ahead.
Sorry, Colin.
Yeah, I think you touched on a couple things that are really key, and again, maybe not so much in people's consciousness, and that's, I would phrase it in terms of the large language models versus the smaller compact models, married with this idea of computing at the edge, right? So right now, what's driving the demand? Where is most of the capital investment going? It's into gigantic data centers that suck up so much energy, and running inference on workloads for chatbots, for example, for customer service and those sorts of things, that are probably running on models that are larger than they need to be. These gigantic 200, 300 billion parameter models, such as GPT-4 or Claude 3.5 or whatever. Now, largely through the open source community and efforts and things like Llama 3 and whatnot, what's happening is we're discovering as an industry that, gosh, even a 70 billion parameter model or 50 billion parameter model, if it's fine-tuned for purpose built for purpose, fine-tuned for purpose, can perform and even perhaps outperform at that purpose. That has to happen if the edge computing idea is going to work, because we're not going to run inference on 300 billion parameter models on a laptop, but 7 billion or 9 billion or even maybe a 30, 40 billion parameter model with the advanced chips that Intel and others are building, we can push a lot of that computing to the edge, and I think what we're going to discover in 25 and 26 is going to really drive, right? The last 2 years, what's driven inference, again, like I said, it's been chat sessions, right? Chatbot type sessions. Mm-hmm. That's going to very quickly change in the next 12, 24, 36 months to agents. And the beauty of agents is they're modular and compact. So you could have 100 of them running, a certain task, or 50 or 10 or whatever. Each particular agent could probably very easily run on the edge rather than in the data center. And this now becomes a fantastic solution to the energy problem, because now you're not having to generate energy, just in very limited areas of the globe where you have these gigantic data centers. You're basically distributing that energy generation across the user base. So I think, Ricardo raised a couple points there, but I wanted to kind of weave the two together.
And I think that those are very interesting points, because it's not just about the energy consumption, it's also about how the semiconductors are getting manufactured. Because then you can also diversify the semiconductor base rather than limiting yourself to those state-of-the-art top-end type of manufacturing facilities, which we have, where we are, while you said we are heavily specialized today. So the question there is, I think both of you touched about the open ecosystem somewhat on the AI side. Could you maybe give some examples of how you see that that's happening right now?
Sure. Well, it seems clear that in today in our economy, it's clear that, for instance, at enterprise level, at business level, also small medium enterprises are looking at AI as a great solution for increasing their productivity, but there are certainly some limits linked to the possibility to scale some of the solutions, and at the same time they have some barriers to entry, because it's difficult to optimize some of the tools, some of the frameworks, software needed for AI, etc. So if we look at an open AI ecosystem where there's a deeper engagement also with the developer ecosystem, this is crucial to lower the barrier to entry, unlocking some of the AI innovations, and freeing up also some resources and time for developers, because some AI solutions are scaled by the ecosystem and driven by companies like Intel. So I think this is important, because in a way it's a way also to free resources for innovation, and so that is definitely a direction that I see as very, very promising in this field.
And just to clarify, when you say open AI, we are not referring to the company. We're talking about the concept of having an open AI,
an open approach to AI.
To the AI.
Yes.
Colin, your views on this?
Yeah, I'm glad you clarified that. I was going to say the same. I think we're not talking about that open AI. We're talking about the other open AI. Yeah, no, I think the open, collaborative approach to AI in an open way is really important, and it really needs to be supported by these international cooperations. And I would love to see, that sort of directly woven into future agreements, where there is sort of an agreement to put these open initiatives, on an equal footing with the proprietary approaches. And this is not just only across the foundation models as well on sort of the software side, but there's also a lot of opportunity on the chip side, the chip design, and even on the chip manufacturing side. I'm sure Ricardo knows well that there's a lot of open ecosystem type of approaches, that are underway now to help sort of democratize the ability to design, build, and manufacture the next round of AI processors, right? So this is something. I mean, all due respect and hats off to NVIDIA, to just to name names, but having a single player at 93% sort of share isn't sustainable. I mean, they know it, we know it. So I'm just going to say it bluntly. I think there needs to be, sort of a leveling of the seas a bit, if it's going to be sustainable.
And that's where I think the roles of government becomes very, very crucial. I think you did, Ricardo, talk about the EU Chips Act, for example. We have obviously had the initiative like the US Chips Act, and a lot of other governments are incentivizing the semiconductor manufacturing aspects, especially. How do you see the role of government in fostering such a sustainable semiconductor ecosystem? Do you think there are certain critical aspects of such policies that we need to look into specifically to ensure there's a long-term viability beyond the initial funding?
That's a great question. I think that, well, we said also earlier that manufacturing in the US and in the EU has a huge cost disadvantage versus other locations around the world. So the role that governments can play in the long term is critical in working closely with industry to make the semiconductor ecosystem not only vibrant and viable in the short term, but making it competitive in the long term. I would say there are three key areas to look at. The first one is the industrial costs, the cost of operations in a specific geo. Second one is an ecosystem approach, the idea of creating a semiconductor ecosystem and not only focusing on individual investments. And the third one is about creating the right talent pipeline and the right skills for this ecosystem. When I talk about industrial costs, I clearly think of energy costs, and I'm in Europe, and I know how the energy costs, the energy bill has become probably the biggest item in terms of operational costs in this region. The cost of workforce is definitely an important one too. But probably what is more important to highlight is the fact that regulatory burdens and especially some of the slow procedures regarding permitting, planning, and so from environmental permitting and other things, there's a clear need for fast track procedures, because this is what slows down the business, creates a lack of predictability, lack of clarity, etc. If we look at the vibrant ecosystem, I specifically refer to the need for attracting investments around big manufacturing facilities. So suppliers, those that are not only able to provide fab equipment, but also chemicals, and those other industrial players that make not just the semiconductor ecosystem, but the entire industry more competitive. And finally, as I said, the third point is the talent skills. So on the one hand, working closely with industry to create the right curricula for the semiconductor sector, right? But at the same time, working to upskill and reskill the existing workforce, bringing people from sectors that are suffering, right, that are more in a crisis situations to sectors that, on the contrary, need more workforce. And this is where it's important to invest more in vocational schools and not only in universities, because the semiconductor sector needs a lot of technicians besides engineers and PhDs. So these are probably areas that governments should look at more closely in close collaboration with industry.
Colin?
Sure, yeah. Well, I'll start with that last point. I completely agree with Ricardo around workforce development and talent and training. I think sometimes the budgets get allocated, both for the CHIPS Act and the EU Act. And even though there are funds and there's components of both of these acts that support workforce development, the danger is that will sort of be the second priority and move too slow. And sometimes we think, to bring on capacity, that it's a bricks and mortar and rolling machines onto factory floors that are the limiting factor. Well, you can build all the buildings you want and equip them with all the power that they need and bring in all the chemicals you want and bring in all the equipment you want. That doesn't mean you're going to produce high yield chips. Yeah. There's a human element here that I think is underappreciated, just the complexity. In spite of the automation and AI and all the rest of it, there's still a gigantic engineering and technician-driven talent component to making these things work. And so my thought on this is, I'm going to make 2 points. One is around funding. So I already kind of little touched on that. I think probably should look at if enough is being allocated and invested into the workforce development side, beyond more the equipment and bricks and mortar side. But the other is, I think we need to grow the collaboration to being more than U.S. and centric, EU centric, and U.S. EU collaboration. We've got to bring other parties in, and I have kind of an idea around that I want to toss out, which is, it seems like in the last 24 months, partly fear-driven, which is okay. There's been massive collaboration around responsible AI. We've all heard this term, right? Responsible AI. I know Access Partnerships talked a lot about this, put reports out about it. And whether it's the G7 or whether it's the APEC group or whether it's UN commissions or, there's all of these. There's the new AI law in the EU. There's ones cooking in Washington, D.C. right now. There's ones all around the world. And what's great about it is there's a conversation happening. What we need to do is raise the consciousness amongst those policymakers that the semiconductor component and the semiconductor supply chain component and the semiconductor workforce development and talent component is a vital component of that overall success.
Yep.
And maybe get those people. Sometimes we tend to be too much in silos, like, well, we're the hardware folks. Those are the, software and policy people. We don't ever get together in the same cocktail parties. No, but I think we need to, broaden this and take it on as a broader technological innovation discussion that involves both, that marries all the fantastic work and collaboration. It's actually impressive, the amount of collaboration on responsible AI right now around the world. If we can also bring some of that collaboration and excitement into this topic as well, and then address the funding component, because let's face it, yes, the amounts are certainly meaningful. What is the CHIPS Act, 53 billion or something, but that's not going to last very long. Let's face it, that's like a down payment. This is going to take a lot higher investment than that. And it seems like if we marry it to AI, there's a mechanism to understand ROI, because what are the forecasts are what 100
trillions of dollars.
$10 trillion GDP boost over the next decade from AI productivity, right? Well, that 10 trillion doesn't get realized if we don't have the semiconductors to power it. So if we want to realize that, we need to marry these two things together and maybe get more broad-based global cooperation.
And I think that's where the AI tech stack sort of makes sense, because you're talking about why you have application and ethics and frameworks at the top. At the bottom, even before you have LLMs, you have chips, you have semiconductors, because without that, none of this is actually feasible. So you're building on top of each other, and that's where it makes it a key component. And Ricardo, I think your points are very valid. I think when we talk to, or when we look at projects which have not taken off the ground, the deal breakers have been lack of skills. We have had some projects, massive projects you see in news, which have not taken off the ground simply because there were not enough skills. And creating that pipeline takes time. And the number 2 issue is location. And when I say location, I mean the fact that they don't have access to affordable, clean power, or access to water, or access to the transport ecosystem, which you require to actually ensure the supply chain is resilient. We have been talking about manufacturing side of the supply chain. We haven't really even touched on the other aspects, and that's where it becomes much more complicated when you're looking at the end-to-end supply chain resilience when it comes to semiconductors. And the third big issue, I think, and you did allude to that, is the bureaucratic processes which have made disbursements a lot slower. There's been a lot of red tape in some of the processes for companies to actually, so if the processes could be made simpler, that would really help take this off the ground and let the market, I think market is smart enough to know where to invest and how can they create this ecosystem. So the government, the role which we talked about could potentially be the role of an enabler there. Which brings me to the next question, which I think is always underappreciated when it comes to, or has not been part of a larger communication. I think that's what we were discussing earlier as well, which is the R&D collaboration. Uh, we the chips acts typically talk about there is some provision of R&D, but we haven't seen a lot of international collaboration when it comes to R&D. How crucial is collaboration, international collaboration, when it comes to R&D for semiconductor industry? How do you see the we can balance the rapid advancements the industry is seeing with some of the R&D, let's say on environment sustainability, some of the lithographic processes we talked about? How do you see that happening? Maybe Colin, I'll start with you this time.
Yeah, well, to be honest, this is a huge challenge. So I can speak as, again, someone who's been at it for 43 years. The competitive nature around IP was there 40 years ago, and it's still there now. For example, semiconductor factories rarely put their data in the cloud just because they're paranoid, that any of the engineering data somehow leak out of the factory. So this is going to be a difficult one, because on the one hand, we're facing common challenges around the next generations of technology, but we also are so deeply ingrained around secrecy and competitiveness when it comes to protecting IP and IP rights. So I'm not sure if I really have the crystal ball, to resolve that, other than to make it part of a multifaceted plan, right? So and again, that's what's happening. So I'm not saying that's not what's happening, but make sure that these initiatives that are underway don't exist in too much tunnel vision, that they are very holistic. Like Ricardo mentioned, like the workforce development, we chatted about that already, right? So we need to take all of the elements that have to come together to build long-term resilience and sustainability for the industry. And absolutely, the next technological wave is part of that. But I don't really quite know yet how maybe there needs to be better mechanisms for licensing of IP amongst participants. This did happen actually in the 80s and 90s, largely driven by SEMI. In the early days, there were industry roadmaps that were drawn up in the 80s and 90s to share, technological development. And I think there was a lot more like sort of cross licensing of patents and capabilities and sharing of technology. And I think we kind of got to get back to that.
Ricardo?
Well, excellent points by Colin, and actually, indeed, IP is one of the biggest assets, and the fact that R&D and investments in R&D are so expensive. It's so difficult to push the boundaries of innovation, to stay ahead of the curve, right? And so at the same time, we are facing common challenges worldwide, and we must collaborate more. We mentioned the environmental aspect and the environmental impact of semiconductors. So now there's clearly a need to come up also with solutions for some substances, chemical substances, for instance, that are used, but that somehow where somehow we need to find alternatives if we want to meet some of the sustainability targets that countries have, that countries want to meet in the coming years. So the work on persistent chemicals, or PFAS, is another one where industry that industry is facing, and where industry needs sufficient time to develop innovative solutions, alternatives to these PFAS. But at the same time, it's something that we face in Europe, in the US, in Japan, in Korea. And I'm aware of some efforts done by SEMI to try to bring together the different efforts. But probably it's also in the context of those closer partnership among governments, US, EU, Japan, etc. Those digital partnerships where some of these R&D areas should really be front and center of the debate, of the conversation. Definitely, more could be done in terms of pre-competitive R&D. So all those steps that could definitely benefit from a closer collaboration of the different international players.
Yeah.
Excellent points.
Yeah, actually, maybe could I just add to that last point? Because one thing we haven't touched upon is partnership with academic institutions, right? And I think to what Ricardo said a little while ago, it's so true. It's so expensive to do the R&D work for this that it's very difficult for the university, labs to participate. But there's tremendous talent pool there. So I think maybe part of this international collaboration is also to bring in the educational partners and combine that with, I think maybe I'll also sort of fish back to early in the discussion about this idea that the supply chains are so highly specialized. So even though they appear to be so global, actually, if you take a look at any one narrow element of that supply chain, it's a bit tenuous. So there's an opportunity for a win-win, right? Because it's kind of like, okay, I'm going to license the know-how around these narrow areas to you, but you have some areas of specialization that I don't have, and we can swap, right? So now we both win because we both broadened our capability, and the supply chain wins because it's more diversified. So I think maybe those two ideas are, to see where the win-win deals can be cut, and then to invite back in a stronger way the academic sector to be involved in R&D.
And those are great points because, for example, CHIPS Act has an R&D component. For example, the US CHIPS Act. And just last week, National Semiconductor Technology Center, they announced a strategic plan on R&D, like how can they basically do. So it's not a company-specific one, but it's something which will provide open innovation for the overall ecosystem. And then you can have this global collaboration with such technology centers together with private sector, bring academia through these mechanisms. And that will somehow not only speed up the innovation, but also ensure that the benefits are a lot more spread out. And we ensure the innovation is a lot more resilient as well, is spread out a lot more in the ecosystem. I just will have one more question before I open it up for just key takeaways from both of you. One question, we have talked a lot about the role of semiconductors for AI. I just wanted to understand your perspective on the role of AI in semiconductor industry. We see a lot of impact how AI is playing in not only in manufacturing but also in the design of chips now. Any views on that? How do you see that AI impacting the future of semiconductor manufacturing and design?
Oh, it's essential. It's not only essential; it's already a fact. We sort of have this virtuous cycle already in place, right? For example, these new GPUs, families, where we literally have hundreds of billions of transistors that need to be routed on a design with so many multiple layers, masking layers. There's no possible way the traditional layout software could optimize that. So AI is already a major component. That's nothing new. That's pre-gen AI, right?
Yeah.
Using AI tools to, for example, optimize chip design and layout. That's been there. And then I think the exciting thing, I'll mention an area that is unlocked by Gen AI, and we've actually had some discussions with some of the chip sector here in the Philippines on this topic. There's a tremendous amount of unstructured data still in wafer fabs, believe it or not. Even though everything's been sort of so automated and everything is like logged, and all the machines are logging all of their data, so all of that is highly structured and available, and IoT is all over the place in a wafer fab, for example. There's still actually a lot of information locked away in unstructured data, especially around things like, for example, equipment maintenance logs, for example, right? A lot of that is still narrative by the maintenance technicians. So the ability to unlock insights from that unstructured data to raise, for example, uptime in a factory is a very exciting new thing that's on the radar screens. I think that's one area where the new Gen AI can play a role.
Ricardo, do you think we'll go from 3 nanometer to 1 nanometer?
Sure. Well, we should be able to definitely go below 2 nanometers next year. So let's wait and see there. But I agree with Colin. AI is already there. I thought of some projects in smart manufacturing where we use AI also to optimize some of the processes in the chip manufacturing itself, where AI also helps us through those insights, right? Improve our sustainability performance in the fabs. I also like a lot the idea how some innovation in chips, and I'm thinking of some security enclaves that allow to protect some of the AI models in the chip. So at the basis of the stack at the hardware level, and make AI more secure. So as Colin was saying earlier, the AI and chips are so much intertwined. And I like a lot the idea of somehow riding the wave of AI, to also rebrand the semiconductor sector as also more, in a way, more appealing also for youngsters to start studying and deciding one day to be part of the semiconductor world, and work there and make their impact in driving innovation.
Yeah, and it goes beyond branding. It's actually the reality today. AI is semiconductors effectively. So, Colin and Ricardo, just final takeaway. What is the one thing which excites you most about the future?
Well,
It's hard to pick one. I mean, even though we just spent almost the last hour highlighting all of the very difficult challenges that we have to overcome, I for one am incredibly bullish about the future. I believe we will find resolutions to these challenges. We always have, and I don't see that running out of steam. And I used the word a minute ago about virtuous circle in terms of the AI in the factory. I think that's what, to pick up again on this point of marrying the AI wave with the semiconductor roadmap, making it one roadmap, is a virtuous cycle, because literally the advancements in the chips drive the advancements in the AI, which then drive the advancements in the chips, which drive the advancement in the AI. Yeah. It's very virtuous, so I think that's what really excites me, is that we have a flywheel going and we got to keep it going.
Ricardo?
I mean, probably there has never been a more exciting time to work on semiconductors, right? So semiconductors are so critical for the entire digital infrastructure. They play a critical role for cloud. They play a critical role at the edge. They play a critical role on the network for connectivity. So this is what really excites me at the moment, and being part of this discussion, of the policy debates, and finding solutions. And I also share the same optimism as Colin said, that we can find good solutions, but dialogue, collaboration, those are the key ingredients for making this happen.
Yes.
Thanks both. What I heard was the four opens. We should continue having open dialogue to ensure open AI ecosystem, open R&D, and ensure open supply chains as well. And more importantly, long live Moore's law. Thank you very much, both of you, and thank you to all our viewers and our listeners today. Thank you very much.
Thank you.
Thank you very much.